ठीक है, थैंक यू, थैंक यू। ठीक है, ठीक, हम जल्दी जल्दी ख़त्म कर देते हैं। ठीक, ठीक। So sorry for the delay and misunderstanding. Uh, so this is the device which I was telling you about, is fire safety device. For that I'll be using a flame sensor. So flame sensor looks something like this. You might have seen IR sensor. So this is the flame sensor. If you can see, there are three terminals here. One is VCC towards my left. The middle one is this ground, and the right side terminal is digital out. So whenever this receiving infrared LED detects some light or some infrared signal, it triggers a mechanism which sends a digital output signal through DO or digital output pin. Okay, so we'll be using this mechanism to detect fire or heat uh, in our room. Okay, so for this we will be using jumper wires to connect. So we'll be connecting this with a lithium ion battery. So I'm using this platform to mount the sensor here so that it can detect the fire. So now I'm mounting the sensor. So this is how my sensor looks. So this is an experimental arrangement which I am making here. You can keep this sensor at the boundary of the place where you want to like detect the fire. For example, you can have this sensor little bit close to the thing which you don't want to get burned. For example, if you have a room heater, you can, if you put this sensor near the room heater, obviously it will detect the heat or that bonfire. But if you keep it far away, the fire reaches to a certain distance, then it will able to detect it at a distance. So and then it will trigger the defense mechanism. So here I have this infrared sensor, uh, this flame sensor actually, and I'll be connecting the pins to this flame sensor. So I'll be connecting digital out. I'll be doing this using jumper wires. See, I'm using jumper wires. This middle one, ground, and VCC. Now I'll connect these to a lithium ion cell. Okay, this VCC and uh, ground. So this is the cell I am connecting this to. And now, and to trigger the defense mechanism, I'll be using a relay module. Okay, so with the help of the relay module, we can power up devices which are more like power consuming than this flame sensor. So this flame sensor operates at around 3 to 5 volt. Okay, so but if you want to like flame sensor is detecting, but you want the defense mechanism to be a powerful device. For example, you want to be a fire extinguisher, or water pump or a big fan, things like that. So for that you can use this relay. So this relay has two circuit. You can attach two circuits. The primary circuit will be attached this side. This side will have a VCC, which is 3.7 to 5 volt, and a ground, and then input from the your sensor. In this case, we are using flame sensor. And this side you can have a common, which will be the supply voltage, which can be of any value, even the AC current supply voltage you can use. And you can attach the second one to the NOP. So this will complete the this will be a open switch circuit, and whenever the signal this receives the signal from flame sensor, it will trigger an electromagnet which will pull the switch and complete the secondary circuit. So by this way, your sensor which works on a 3.725 volt, you can use that sensor to operate a very heavy, high power consuming device also. So here I am attaching the pins to the relay module also. So we have a VCC here. You can see we have a, if you can see, we have a in which will take the digital output from the flame sensor or any sensor for that matter, which gives out an output. There is a ground and there is a VCC. So I'll be connecting VCC, and I'll make this common for both flame sensor and this relay module. So VCC and ground I have connected, and I'll connect the digital output directly. Okay, you can hear the click sound. And this pin for VCC. Now I will paste the battery and connect the wires, and I'll show you the connection. So one is for this sensor and one is for this battery. I'm using double tape to connect these, to stick it on my sun board. So this is how it will look. Okay, so I have my relay for primary circuit. I am telling you, I have my relay, I have my sensor, and I have my battery connected. Now here what you can do is you can have a switch in one of the in the ground. Okay, if you have a switch in the ground, you can switch off this primary circuit. Okay, now what I'll do is I'll arrange the secondary circuit. For secondary circuit, to extinguish fire, I'm using this fan here. Okay, you can use that pump also to like spray water, or a carbon dioxide gas can you can operate in the secondary circuit which emits carbon dioxide. Or maybe for an electrical short circuit fire, you can use a dry sand falling mechanism. Okay, so but for here I'm using this fan. But I'm warning you, if you are using fan on fire, at times it may like make the fire even bigger. So but here we are using fan, and we'll see, we'll not like make our fire bigger. So this fan I'm attaching on a raised platform. First let me stick the raised platform. Okay, I'm using super glue for that. Okay, so please always be careful with the super glue. After use, close it and place it somewhere else. So now this is the arrangement I am using, and I'll stick the fan here. So before sticking the fan, let me attach a 9-volt battery clips to the common. So I'll be attaching the VCC of the 9-volt to the common of the secondary coil. So sorry, secondary circuit of this relay module. So this is where I am attaching it. And I'm using this to tighten the screw. This will go nowhere. Done. Now just for the sake of seeing that my circuit is working properly, I am using this SMD LED to detect whether my circuit is working properly, and I am using it in series with the fan. You can totally avoid using it, or if you want to keep it for your educational purpose, that you want to see whether your circuit is connected or not, or maybe your motor is working or not, you can always put some bulb in series. So now I am connecting the secondary circuit. Both of these I have connected. Oh wait, it didn't connect. So now I'm using this. Okay, it's not connecting. We try once more. Cut the wire a little bit. To use this thing. Okay. So now again I'm trying to see if I can go. Okay. And this fan I'm attaching on this side of this so that it can like stay above. Okay. The secondary battery now I'm attaching. Then we check the circuit at once. Now I'll attach the battery properly using a double tape. I'll show and explain this to you. Once, let me please allow me to attach this battery. Battery done. LED. Okay. So this is how I've attached the battery. I have attached this positive of the motor to the negative of the LED in series. So whenever this current LED must go glow is complete. You can totally avoid this. This I have used only like felt like I should use this to see if my circuit is working properly or not. You can totally avoid it. Now this is the arrangement which I have. So you can see my flame sensor is here, which is my primary power source is here, which is powering the flame sensor and the primary coil of the relay module. Okay. So now what I will do is that I will light a matchstick and see if the circuit is working properly or not. I'll try to bring the matchstick close, fire close to this and see if it is working or not. Okay. So if it will work, then this infra so this flame sensor will detect the heat, the infrared infrared light, and then send a signal. Will reach the relay, primary coil of the relay, and that primary coil will get activated, create a magnetic field, and turn on the switch for the secondary coil. And once the secondary switch is turned on, this SMD LED, which you see I have pasted on the battery, and this fan both should run. And when the fan runs, it should blow off this fire. Okay. So now I'm lighting. So see, it is detecting from quite far away. Okay, this is my fire. I'm bringing close. See, it extinguished. So even this small, this thing, remaining fire, it is able to detect and has completely blown off this fire. I'll show you again, maybe more clearly this time. So this is the matchstick. Fire lit up. This is my fire, and just see when I bring it close. So see, even remaining fire till it is turned into ash, like it is burning. Sorry, it is the fan was running. So the flame sensor was able to detect even minimum of the fire when close to it. Now what we can do when we are making this at the boundary of the place from where beyond which we don't want the heat to go. For example, if we are lighting a bonfire in the garden, we can keep this device close to the boundary wall of our boundary of our house, so that if the fire gets close to the house, so this system will trigger a defense mechanism. This fan can be spread out in the place, or sorry, if you, instead of fan, you can use a water spray mechanism, which can spray water and extinguish the fire. And that water spray mechanism can be close to fire or close to the house, depending on where you want that to happen. Okay, so this is the circuit where I have used only very simple without Arduino. We can make this. I have used a sensor, flame sensor, and I have used a relay module. These two devices you need to make this circuit. And even for relay module, you can use a 5-volt relay and attach this BC547 transistor, make it work. But it's always better to have a relay module. So this is my complete model. I hope you learned something and enjoyed the YouTube live. So if you have any questions, please do let me know. I'm still here. So if once you make this thing, you feel like playing around more. So let me light the fire once more time and see what happens. Like when I was experimenting this, I had tried with candle. Okay, so candle also it was blowing off, but then after some time the candle would light up again, and then again the fan would start. So again I see the matchstick. So this is the distance it's detecting the flame. So if the intensity of flame goes down, you need to get it has to be closer for that. Okay. So this is done. See, this is totally extinguished now. So no questions. Nobody is asking any question. Any comments about it? Did you enjoy this? Would you like to make something like this with your student? Anyone? No comments? So if you have no comments, you can write back feedback to us that what did you like in this YouTube live, or what changes you want to make in this YouTube live. Do write us. Do write it as anything. How the sensor is working. Okay. So there is a principle called photoelectric effect. So if you know the person's name, his name is Einstein. I think you might be familiar with that person. That person gave a lot of theories like special relativity, general relativity, and that famous energy mass equation, and all these things revolutionized. But for one thing, he got Nobel Prize, and that one thing was not general relativity or E is equal to mc square. It was photoelectric effect. So photoelectric effect in physics is a very paradigm shift. It changed physics totally. What happens in photoelectric effect is that when a certain frequency of light hits a material, it generates electric current, and that proves that that sorry this electric sorry light wavelength of the light, which is a wave, which we used to consider it as a wave, also has a particle, because only because of that it is able to displace the electron. So this way, whenever there is the light coming to this sensor, there is a special material which only works for the infrared frequency. You can have that material changed and it will work for ultra frequency also, or a visible light frequency also, but here generally it is infrared frequencies. So I think, but if this material has infrared frequency, it should work for visible and that ultraviolet also, because the energy is higher in ultraviolet and visible from infrared. So whenever any light above with infrared frequency or higher than infrared frequency hits this, it collides with a material which generates an electric current due to displacement of electrons, and that the electric current is sent out, and that digital out electric current is able to switch on the primary relay module, which is basically an electromagnet. So it turns on the electromagnet, and that electromagnet creates a magnetic effect which switches on the secondary switch. This is the working principle. If you bring this flame sensor in direct daylight, no, then also it may start working. So in direct daylight, it may start working, but in this room light, it may not work. For example, let me see if it can work or not. I'm using this torch. See, it is not working. Okay, but in sunlight, it will work because there is a wave has a good amount of frequency, and intensity doesn't matter, but frequency matters in these photo sensors. So, any more questions? So you might be familiar, just one trivia I will give you before you go. You might be familiar with that IR sensor in your robotics lab if you have Tan90 Nutcut lab. IR sensor which we use to make the automatic water detection, sorry, automatic water dispenser. So very similar to that, this sensor, and it has a LED which sends a light and which collides with the obstacle and received by this. So uh, till next, I hope you enjoyed this, and you can like make very similar models or experiment with yourself, and change the sensor. For example, you can like try it with the smoke sensor or PIR sensor. Okay, ultrasonic sensor, I don't think it will work. So these sensors which have like only 3 terminals, you can try with them and see like what devices can you make. Okay, so thank you so much. Till next time we meet. So I'm sorry for the delay, there was some confusion, but till next time, all the best and keep making projects. Thank you so much.